So this video will explain about some theory background in the second experiment, which is the flow over immersed body. So before we start with the theoretical calculation, let's have a look to these four basic aerodynamic forces on a vehicle, for example. So imagine your vehicle is moving towards to the left hand side direction with a constant velocity. So to make this object move, so we have engine. So this engine basically will produce momentum to push the object move forward. So this force is exactly known as the thrust force. Okay, so opposite direction to the thrust force is exactly known as the drag force, or in layman terms is simply known as resistance. So in the vertical component, pointing downward is always due to gravity, so that's why we have weight mg. So opposite to the weight will be the lift force. So in other words, in order to make the object lift, so the lift force must overcome the weight force or the weight of the body. Okay, so if you refer to the objective for the second experiment, flow over immersed body, so we are to measure the drag force on an aerofoil and also to determine the drag coefficient for this aerofoil. So drag force, as mentioned, is a resistance. So it is exactly the summation of different form of resistance. So first of all, we have pressure drag, or some reference book they used to call it as form drag. So other than this, we have skin drag. So skin drag is mainly occur on surface. Pressure drag is mainly caused by the change of pressure in two regions and then acting over a surface, so it will contribute to pressure drag. So the third form we have, which is called induced drag. So this induced drag is like wingtip vortices. So imagine this one is aircraft. So at the tip here, due to high pressure at lower surface and low pressure on the upper surface, so the high pressure region will tend to overflow to the upper surface. As your aircraft move forward, so this is how it's formed the free vortex motion, and we call this one as induced vortices. So we call this one as a wingtip vortices. So these vortices basically will induce drag to aircraft. In other words, when wingtip vortices is occur, so the lift force of the aircraft will lower down while the drag force will increase. So this is known as induced drag. So other than this, we have many others form. So these are the three main forms that we may observe. Okay. So in this experiment, we are not going to measure every single individual drag here, because it is quite impossible for us to determine one by one. So whatever value that you obtain in your experiment will be the total drag. In other words, the value that you obtain from the experiment will be the total drag, and this total drag basically is cover pressure drag, skin drag, induced drag, and many others. Alright, let's investigate what is pressure drag, what is skin drag. and what are the main differences between them. So let's look at the first one, induced drag, pressure drag. So pressure drag is some sort like when a vehicle or object moving forward. So the frontal surface here will have maximum pressure due to stagnation point. Okay, so this one is we obtained it from the Bernoulli equation. In other words, the pressure acting onto this surface is exactly higher than our free stream pressure. So while the air is passing through this object, so let's say this one is our streamline. Because of the object is not streamlined, so that's why the flow will easily separate. Okay, the flow is easily separate. Separate means the boundary layer is not attached on the solid surface. And hence, when separation occurs, usually this is what will happen. The backflow. Backflow means the flow reverse. Okay, so imagine this is our flow direction going towards to this direction. So therefore, somewhere here we have backflow. So that's why this region we call it as weak region. And usually weak region, it will produce ADs, or we so-called backflow. So what is the significance of having forming these ADs here? So basically ADs, if you refer to some other reference book, so basically this is what they explain, and I quite abide to this explanation. So basically when AD's motion is formed, so yeah, before I forget, so AD's motion, usually the velocity is exactly very, very small as compared to our free stream velocity. So let's assume change of potential energy is negligible. So from what we have in our energy equation, so we omit the heat terms, or we omit the work terms in our energy equation. So it is simplified back to our Bernoulli equation. So if you refer to Bernoulli equation, we have pressure, flow work, or pressure energy, then we have kinetic energy, and then we have potential energy. So since equal to constant, so since this term is negligible due to the elevation is about same, so and the kinetic energy in the weak region is very small, so we tends to omit this one. So in other words, these ADs basically will consume our pressure. So after it consumes the pressure, where does the energy goes? So the energy later on will convert into heat energy. So that's why in this region here, in this backflow region here, the pressure will drop significantly. And as mentioned, when pressure drop, so the energy is now converted into heat energy. So now let's see, when the pressure behind the object is now reduced, so while the pressure in front is higher than the one behind, so let's take a very simple concept. So force is equal to the change of pressure multiplied the cross-section area. So this cross-section area is simply referred to the frontal area or the projection area. Okay, so in other words, as your change of pressure becomes significant, for example, let's call this one as P1, let's call this one as P2. So as P1 is much higher than P2, so it will lead to your change of pressure become more significant. So that's why this is how it contributes to our pressure drag. In other words, when our object is not streamlined or the backflow region is very large, okay, the region is very large, so usually the change of pressure will become significant due to the pressure drop in the weak region, and therefore it contributes to our pressure drag significantly. So this is the concept about pressure drag. So now let's go to the second drag force, which is the skin drag. So skin drag, as mentioned, is only occur onto the skin. So you see, as a flow passing through the solid surface, which is parallel to the solid surface, so somewhere here it will create skin drag. So usually skin drag is mainly caused by the shear stress, okay, which is the dynamic viscosity multiply the velocity gradient, and then we multiply this shear stress with the parallel area, and hence we get the skin drag. So now what is the main difference between, or what is the significance between this pressure drag and skin drag? So imagine, so in this experiment we are about to investigate the drag force onto an aerofoil. So one of the assumptions made in this experiment is that we assume this aerofoil is a thin object. So for thin object, when the flow passing through this aerofoil, so this will be like this, the streamline. In other words, for a thin object, usually the backflow region is very small. So when the backflow region is very small, the change of pressure or the pressure drop in this backflow region is exactly minimized. In other words, when the backflow region is small, usually the pressure drop in the weak region is not significant. In other words, when I have a thin object like this, the pressure drag usually is minimum. In other words, when my pressure drag is minimum, so usually the skin drag will be our dominant one. Okay, skin drag will be our dominant. So as we start changing the angle, so for example, start change to have higher angle of attack, something like this. So this one is alpha. So we call this one as angle of attack. Okay. So same, we have free stream velocity passing through this object. So when we have thick object, so the flow will easily separate, or in other words, the flow will separate earlier than the one we have in thin object. So usually for thin object, the separation point is occur towards the end of the object. But when you have a thick object like this, most of the time the separation point will occur earlier. Okay, so let's say somewhere here. So in other words, when separation point is shifted earlier, so the backflow region is now become wider or bigger, and hence this region, okay, it will produce a very low pressure, and therefore when separation region is bigger, so the dominant drag force is now dominated by our pressure drag. In other words, when I have a thick object, the dominant drag force is pressure drag. For thin object, the dominant drag force is skin drag. So in this experiment, so we assume the aerofoil is a thin object, and we will start tilting. Okay, we'll start changing the angle according to given one: -5 degree, 0 degree, 5 degree, 10 degree, 15, 20, and 25 degree. So as the angle increase, so again we will assume the object is still very thin. So that's why when we have this equation, the general equation to evaluate our drag force, which is equal to half rho u infinity square multiply the cross-section area and then multiply the drag coefficient. So this will be the general equation to evaluate our drag force. What is density here? So density is referred to the medium that passing through the object. So let's say this one is air. So therefore, the density will be air density. How about your free stream velocity? Free stream velocity is simply referred to the velocity that passing through the object. And what is the area? So for area, since we assume the object to be thin and the dominant drag force is come from the skin, so therefore we will take the shear area. What is shear area? Shear area is that when the flow passing through the object, so the dominant drag force is only occur on the shear surface here, or the shear area here. In other words, the area is simply given by the chord length of the aerofoil multiply the span width L. So in other words, area for our case here will be the chord length multiply the span width. How about a CD? CD is a drag coefficient depends on a different angle, different geometry. So in this experiment, we are going to determine what is our CD. Based on the drag force we obtained from the load cell reading, so we will convert it into Newton later on, and we put it into this equation to figure out what is our drag coefficient. And after this, you are required to plot the angle of attack and the drag coefficient onto these two axes. So this is for the first experiment objective. So second objective in this experiment is to determine or to calculate the pressure coefficient on the upper surface and lower surface. So upper surface simply is referred to here, okay, the surface on top, and lower surface is referred to the surface on the bottom. So if you refer to the manual, there are 7 points on top, okay, there are 7 points on top and 7 points on the bottom surface. So you are required to determine or to measure the pressure on these 7 points on upper surface and 7 points on the lower surface based on the equipment provided to you at different angle. So in other words, one reading here, you need to have 14 pressure readings, 7 for the upper surface, 7 for the lower surface. So after this, you are required to substitute or to use this equation to evaluate your pressure coefficient. So what is pressure coefficient equation? So pressure coefficient is simply given by the change of the pressure on the surface over the dynamic pressure. So what is change of pressure on the surface? It is simply referred to the pressure on the surface minus the free stream pressure. So in other words, before any air passing through this aerofoil, so we have same pressure acting onto these 14 points on upper and lower surface. As start flow or passing through this aerofoil, and you will notice that due to the different geometry occur, so it will cause the pressure. Maybe some region you will have low pressure, some region you have high pressure. So that's why this reading will be connected to a manometer board. Okay, is connected to a manometer board, and you're required to record what is the water level rise or down. We will take this reading and convert it into our change of pressure later on. Okay, So after this, you are required to plot CP against the chord length. Of course, at every single point here is measured from the starting point, where starting point is x equal to 0. So at this point, you will have x1, x2, and so on. So later on, the coordinates of these 14 points will be provided to you, and you need to take x1 over the c as your y coordinate. In other words, when you plot your graph, you have something like this: the x over the c, the coordinate over the chord length. So minimum value always 0, maximum value always equal to 1, while your y-axis will be your CP. And we will plot two lines into one graph. So maybe this one, not maybe. So one line is indicating the upper surface, and then the other one will be lower surface, whichever. When you tilt the different angle, you'll notice that the lower surface will be higher pressure. So this means when tilt the higher angle, you'll see that the two lines is actually start swapping. Okay, so this one is based on -5 degrees, for example, and you're required to plot 7 graphs, or based on these 7 angles required, and comment about the result. So this is exactly the explanation for your second experiment. So I hope you guys get well prepared before you go to experiment. Thank you.